Horticulture is one of the most important agricultural sectors to many African countries. It revitalizes rural economies, contributes to food and nutrition security, alleviates poverty through increased incomes for farmers, creates employment and many other opportunities. It is estimated that there are over 500 million fruit and vegetable farmers. But it is not all sweet returns for most of these farmers. The sector faces threats from pests and diseases.
We suffer from a lot of food insecurity and malnutrition, different kinds of malnutrition, simply because we cannot afford the cost of a healthy diet. One of the key subsectors that can tackle the issue of healthy diet is horticulture. It plays also a major role in contributing to income generation, jobs, and various kinds of opportunities for both the growers and people that are working across the value chain, be it from production to processing, to value addition, to marketing, in improving the livelihood of people of Africa. We have a couple of biotic constraints that continue to constrain production, and chief among them is tephritid fruit flies. In Africa, we have a lot of native species. All these species collectively cause yield losses that vary between 40 to 53%. These fruit flies cause damage to various kinds of fruits and vegetables. Citrus, avocado, mango, papaya, tomatoes, chilies are all attacked by fruit flies. And they cause both what we call direct damage as well as indirect damage. Direct damage is usually done by the female fruit flies that lays egg on the fruits. Once the eggs are laid on the fruits, the egg hatch into maggots. Indirect damage is associated to quarantine restrictions that are imposed by importing countries to prevent fruit flies from getting into their country.
In eastern Kenya, we visit Henry Ngare, a farmer who grows mangoes, one of the horticultural crops that is heavily attacked by the fruit fly. He takes us through his journey in mango farming.
When I was teaching, I was interested in agriculture, and I started farming the horticultural crops. I grew some oranges, some avocado plants, and later on I switched over to the mango farming, which I started in 1984 and 85. The first time I planted 120 trees, but I've expanded the population of the trees. Now I have about 400 trees on this farm.
His journey resonates with that of farmers from other African countries.
Mangoes at times ripe at the same time. So we used to encounter a lot of damages or wastages.
We had a problem of mangoes being destroyed by fruit flies.
Effects of the fruit fly continue to have a wide-reaching socioeconomic effects, including job losses, loss of incomes, and trade for millions of populations involved in the horticultural value chains.
I have evaluated the socioeconomic as well as the environmental and human health impacts of the fruit fly IPM. If every farmer is able to adopt the IPM strategy, we'll be able to reduce the loss of horticultural crops that is estimated to be over $2 billion USD, that could then translate to many livelihoods of farmers who are depending on horticulture in Africa. The reduced use of chemicals also translates to reduced risks for the consumers who are using the mangoes, as well as the environment.
What I use per year is actually less than 10,000. There is certain benefit that I use little money on crop protection. With the resources that we are able to sell most of the fruits and get more money than we used to get.
In response to requests from African growers and other stakeholders in the horticulture value chain to address the fruit fly problem, in 1999, ISIPA established the African Fruit Fly Program, targeting 3 major pillars. These include assessing the impact of the fruit fly, developing and implementing affordable fruit fly management methods, and capacity building for farmers.
The key objective was to first identify the composition of the various fruit fly species that are there and to be able to understand the level of damage. The second one was for us to understand their biology, and also we wanted to understand the ecology of the various fruit fly species in terms of what is their dynamics, how do they fluctuate over the season. So all those dynamics were crucial for us to understand the pest before we begin to develop a management tools. And this included developing effective monitoring systems. You want to know when the pest is coming into your orchard, and you have to look at what bait or attractants attracts them for you to be able to monitor that. We also wanted to look at what bait can we use, because we don't want a situation where the growers are applying cover spray of pesticides in their farms.
We found some fruits which are affected by an insect. Many of us did not know what kind of an insect it was. We used to talk to the chemical sellers who are just selling chemicals to kill all the insects in the shamba.
It is now over 20 years, and through the program, ISIPE developed various integrated pest management tools and technologies that have proven to be highly efficient in controlling the fruit fly. These technologies are safe to the users, consumers, and the environment. They have been introduced at a time when consumers are demanding safe food while living sustainably.
So we, for instance, went to Hawaii to get the parasitoids into Africa. And after working with regulators in various African countries, we were given permits to now begin to release those parasitoids. Farmers are not going to use all these many of packages. So we had to look at what 2 to 3 components can then mix together to reduce the pest population.
ISIPE have developed a very holistic approach for tackling the fruit fly problem at both pre-harvest and post-harvest stage. You need to establish the best population on your orchard before any intervention. Once you establish the best population increasing, you start with the baiting technology. And this particular one, it attracts both male and female. The other intervention is male inhalation. By male inhalation, you want to kill as much male as possible to deny female from mating, so it produces unfertile female. Then after that, assume that these fruit flies, they have laid eggs in the fruit. We have also a very efficient parasitoid that we have imported for the invasive species. Like human being, also insects, they get sick. And ISIPE developed by pesticide, and these pesticides have been jointly commercialized with real IBM. These pesticides, they are used in different forms. They are used in what they are called auto-dissemination device, whereby the fruit fly picks the spore and go donate it to the others. In effect, it dies, and also the other which they come in contact with this fly, they also die. We also put this by pesticide under the tree canopies, and all the pupae and the larvae they come in contact with, they also die. Another additional technology which is very easy and any farmer they can implement it is orchard sanitation. All what you need to do is to collect those rotten mango. Before we used to tell them, just dig a hole and dip them, bury them. But now since we are releasing parasitoid, if we do that, we also kill the parasitoid. So we come up with a structure called argumentoria. So those infested fruits, they will be put in the argumentoria. The parasitoid will go back to the system while the fruit fly will die.
But to completely get rid of the pests, the fruit flies, from the fruits, you need to do what we call post-harvest treatment measures.
We work with hot water treatment at a temperature of 46.1 degrees Celsius for different time durations as prescribed per protocol, depending on the commodity that will be treated. For example, this hot water treatment will work on various fruits and vegetables, including bell pepper, French beans, citrus, and mango. For mango, we have a protocol that was developed here at ISIPE. It works at 46.1 degrees Celsius for 68 minutes. That is for apple mango variety.
With integrated pest management technologies making significant strides, the program has benefited over 100 million farmers in over 30 African countries and aims to reach about 500 million farmers. This has been made possible through collaboration with the private sector, especially commercial producers of the innovations by ISIPE.
ISIPE will do all the research work. They won't shelve whatever they've researched on. They'll advise us on what they have researched on and what they found to be viable products. And then as we look at the product that they are on offer, and we'll do markets market strategies and we'll market research, and then out of it we'll see, yeah, maybe product A or product B has some bit of, it's valuable to us as a commercial producer, and then once we take the product, we'll do the commercial production for it, and then we'll sell it to the farmers. And then the farmers will be able to use products that are more friendly health-wise, and then out of it, the product that the farmers are going to sell into the market have all the health benefits. What they've done, that we're able to pick up the best product that will help the farmers and the consumers and improve the livelihood of our producers and consumers in Africa.
Kenya Biology is a company that deals with biopesticides, and we partnered with the ICIPE in 2017. We produced a product called Fruit Fly Mania. Fruit Fly Mania product has been very beneficial to the farmers. It has been able to control the fruit flies in the field, but it has also a multiplier effect to the traders and overall even to the consumers of the product, because they end up consuming a healthy product which has got no withdrawal period after the product has been applied.
14 years later, after ICIPE piloted the innovation on Henry's farm and other farms across Africa, the results are substantial.
We're spending about 30,000 shillings per season on buying of chemicals, and these chemicals were not actually eradicating the fruit flies, which were mainly damaging the fruits. The fruit flies were so disturbing because somebody would come to buy the fruits and find that over 50% of the fruits are actually destroyed by the fruit flies. They cannot go to the market. So if you had harvested a heap, they would select a few fruits and leave others behind. We worked in my farm and I learned all the techniques about their program, which was integrated pest management, that you use different methods to control the fruit flies. It worked very nicely. The loss due to fruit fly damage actually went low until we reached a situation whereby we were losing somewhere between 5% and 3% due to fruit fly damage.
The fruit fly management program, which is called the IPM, Integrated Pest Management, has been very helpful, particularly not only with only mangoes, but also with other fruits which get affected, such as pumpkins, watermelons, as well as avocados.
From Zimbabwe, Malawi, Burkina Faso, Madagascar, the African Fruit Fly program has a presence in 30 African countries. The plan is to intensify adoption of technologies and solutions in these countries and across the entire continent.
The African Fruit Fly program, as the name implies, was being implemented across the whole continent. We were working in East Africa, West Africa, Southern Africa, and North Africa. Although the bulk of the operations were largely done in Eastern and Western Africa. It is important to mention, however, that as we speak, there is an ongoing program in Southern Africa, and we are reaching out to North Africa to expand our operations as much as we can. And this is like a call for action to our development partners that have continuously supported us, including new ones that can come on board, for us to expand this reach beyond the level that we have attained in the current program. Given that the demand is so high and we have only scratched the surface, there is the need for continuous funds to scale out these technologies across the continent.
The need to intensify and scale up these proven interventions by ICIPE has only begun. Join us on this journey as we continue the fight against the destructive invasive fruit fly while striving to provide safe solutions for our people and our planet. For more information on this project, visit our website www.icipe.org.